All right, so in this video you will find some guidance and help for the solving retake ticket. So please use the video as you need it or just to check answers, and make sure to ask your teacher questions if you have any further issues in working through this. So let's go ahead and get started. We're going to start with order of operations and combining like terms. So you can see order of operations on the side there, PEMDAS, parentheses, exponents, multiply, divide, add, subtract. So that's the order we want to go in. So let's get started here. We are going to first start with number 1, and that is where I see an exponent, I see multiplication and subtraction, so we want to evaluate the exponent first. So 3 squared is 9. And then the remaining operations are multiplying and subtraction. So we would multiply next. That would give us 18. And 18 minus 7 is 11. Okay. For number 2, once again, very similar. This time again, I see an exponent. So I want to evaluate that first. So 4 squared is 16. Remember, that's saying 4 times 4. And then plus 8 divided by 2. So out of those 2 remaining operations left, we have addition and division. We would want to divide first. So 8 divided by 2 is 4. And then 16 plus 4 is 20. All right, number 3. Taking a look at number 3. Again, the operations I'm seeing are subtraction and multiplication. But I see parentheses, so I want to do inside the parentheses first. 8 minus 2 is 6. And then multiplication right here, even though there's no symbol, we know that a number next to the parentheses means multiply, and so that means negative 7 times 6 is negative 42, which is then negative 38. Okay. At any point in time, please pause the video and work ahead or work these out on your own before seeing the solutions. Otherwise, keep working on it. Okay. For number 4, again, simplifying means in this case, look at the inside of the parentheses, but 2x minus 9, those are not like terms, so we cannot combine those. So right away, we have to just distribute. Right? So negative 4 times 2x is negative 8x. Negative 4 times negative 9 is positive 36. That's all I can do. I cannot combine those together. Those are not like terms. Number 5, again at this point I don't see any parentheses, I don't see any exponents, I don't see any multiplication that I can multiply it out or division, so adding and subtracting, we're just doing like terms here. Some of you might like to separate those like terms, right? So I see some of you do this, something like this, where you're splitting those terms up, makes it a little bit easier to see which of the like terms or which terms might be alike. So in this case we've got x's. So 3x minus 8x is negative 5x, and then we also have negative 7 and a positive 5. So combine those together, and we end up with negative 2. That's all I can do there. And for the last one in this section, number 6. Again, simplifying, we're looking for parentheses. So x plus 2, nope, I cannot combine that together. So I'm going to just go ahead and distribute that negative 3. So negative 3x minus 6. And everything else just comes down. So 3x minus 4y plus 10 minus 2x minus 3x minus 6. Again, you might want to go through and just separate each term now. So we do have quite a bit going on here. So we're looking for all of the x's. So I do see an x, an x, and an x, so let's go ahead and combine those. 3 minus 2 is 1x, minus 3x is negative 2x. So negative 2x, so we got those. And then this is the only y term I see, so that's just negative 4y. And then I do have a plus 10 and a minus 6, so 10 minus 6 is positive 4. And that's as far as I can go. Those are all the like terms that I've combined together. Okay. Go ahead and move on to the next section when you are ready. All right, so in this section we are solving equations. And so you can see those 5 steps: distributing to get rid of parentheses, combine like terms, move all variables to the left, constants to the right, and then solve for the variable, right? Usually the solving step is the division step at the very end. So let's get started here. Make sure, again, looking for parentheses. If there are no parentheses, are there any like terms? No. 4x minus 12 is not a like term. And so right away, we're going to isolate that variable term by adding 12. Bring down that variable and equals 32. And then the last step, the constant's already on the right-hand side, so we just need to finish by dividing. So dividing leaves us with x equals 8. Okay. Number 2, again, draw your line, and then again, parentheses. Nope, no parentheses. Are there any like terms on either side? No. Here's the variable itself, so we need to get that isolated. So we're going to subtract 8 on both sides. Don't forget to bring down the negative 3m. That's negative 15. And then divide by negative 3. Remember, with division, you are dividing by the same sign. So we get m equals positive 5. For number 3, once again, our checklist, distribute. Yes, we do have to distribute. Okay, so that is a hidden 1x there. Negative 2 times 1x is negative 2x. Negative 2 times 7 is negative 14. And then again, we're looking for like terms. There are no like terms on the same side, so we are going to then isolate the variable term by adding 14. So bring down that negative 2x equals 8. And then again, last step, divide by that coefficient. So x equals negative 4. Just remember, at any point in time, pause the video and try these out on your own first. Or if you are truly stuck, go ahead and continue watching and rewind as needed. Okay, here we go. Number 4. Again, parentheses, yes. So we are going to distribute into the parentheses. So we have 4x. Again, distribute is multiplying. So 4 times negative 9 is negative 36 equals 6x plus 18. And this time, there are no like terms on the same side, but you can see there are variables on both sides. So we are going to subtract 6x from both sides. Cancels out on the right. We get negative 2x on the left. And then at this point, our solving steps are 2-step equations, right? So we're going to add 36 to both sides. So what does that give us? 40, 54. And then divide by negative 2. So x equals negative 27. Okay, number 5. Once again, look for parentheses. If you don't see any parentheses, again, look for like terms on either side of the equal sign. So on the left-hand side, 3x and a minus 7 are not like terms. On the right-hand side, though, we do have 5x and negative 3x. Those are like terms. So I'm going to write everything else down and then combine. So 5 minus 3 is 2x. And then we're basically back to where we started number 4, right? So now we're looking at variables on both sides. So I'm going to subtract 2x to cancel out the 2x on the right. That leaves me with 1x minus 7 on the left. And we've got a 19 to bring down. And then add 7 to both sides. And that leaves me with 1x equals 26. Now, that 1 is a hidden 1. I don't have to write it. I can hide it. And so I'm just left with x equals 26. That's it. And last one, the most complex one out of all of these. So try it out if you haven't yet, and then check your work. So right away, I see parentheses. And go ahead and multiply that out. So negative 6x plus 10, and then plus 5x on the end there. On this side, there are no like terms, so I'm just going to bring down those two things right away. Next step, like terms, right? So negative 6x, positive 5x. Those are like terms. I'm going to combine them together. So negative 6 plus 5 is negative 1x. On this side, we still have negative 6x minus 7. And then again, we're back to, we have variables on both sides. We need to get those variables to the same side by adding 1x. Adding 1x gives me negative 5x minus 7. And two more steps, right? So add 7 to both sides. +7 is 17, and divide by negative 5 on both sides. And so this final answer is not going to be a nice whole number, but that's okay. X equals negative 17 over 5. All right, in this section we are focusing on equations with fractions in them. So that would be just regular equations with fractions and proportions. So equations with fractions in them. Keep in mind that a lot of times what I like to do is I like to isolate the variable term first. So I would subtract 1 on both sides to leave me with x over 3 equals 6. The other option here is, let me copy down the problem. The other option is to clear that fraction right away. So some of you might remember clearing the fraction, and if that's the case, what you need to be doing is multiplying everything by 3. Every single thing in that equation gets multiplied by 3, which cancels out your fraction and leaves you with x. 3 times 1 is 3, and 7 times 3 is 21. So if you clear the fraction right away, you're left with an equation that no longer has any fractions, and we can just subtract 3 to get x equals 18. Now we should get that same answer if we finish up solving it the way that I initially started. So I am now going to multiply both sides by 3 over 1. So remember, multiplying by that reciprocal, or flipping the fraction. Multiplying by the reciprocal leaves me with just a 1x, right? Because 3 times 1 is 3, 1 times 3 is 3, 3 over 3 is just 1, right? So that turns into 1x. On the right-hand side, I have 6 times 3 is 18, 1 times 1 is 1, 18 over 1 is just 18. So once again, that hidden 1 doesn't need to be written, x equals 18. So 2 ways to do the same question. Okay, for number 2, again, same approach. You could either multiply every single thing by 4, which notice is the denominator of that fraction. If you do that, and do that work over here, if you do that, then you would be left with 3x minus 20 equals 40. So that's one method. Or what you could do is add 5 to both sides and start with 3 over 4x. And if I add 5 to both sides, then that is now equal to 15. So these, again, are the 2 methods in solving an equation that has fractions like this in it. Okay, either way you do it, you'll end up with the same result. In this case, continuing by multiplying by the reciprocal. So again, my 4 over 4 cancels out, 3 over 3 cancels out. I'm just left with x equals 15 times 4 is 60. 1 times 3 is 3. 60 divided by 3 is 20. So I should get 20 over here as well. So if I add 20 to both sides, 3x equals 60 divided by 3. X equals 20. Different ways to do the same question. Okay, for proportions, notice there are fractions, but we handle proportions by cross multiplying. Okay, multiply being the key there. Okay, so for this first one, I can see I have a fraction set equal to a fraction. So I'm going to put parentheses around the 2x minus 6 to group those together. And then I'm going to set up my cross multiplying. So 8 times 2x minus 6 equals 4 times x is 4x. So that's the cross product. That is cross multiplying. And now we just need to follow through with the distributing and solving from there. So distribute 8 times 2x is 16x. 8 times negative 6 is negative 48. Bring down your 4x. From here, I have variables. Notice I have variables on both sides of the equal sign, but they're alone on the right-hand side, so I'm going to subtract the 16x to get it to the other side. So don't forget to bring down the negative 48. 4 minus 16 is negative 12. And then we are ready to finish solving. So we're dividing by negative 12. And x equals positive 4. Number 2, again, in each of those fractions I see the denominators need to be grouped. So that helps me remember that I'm going to cross, when I cross multiply, I need to distribute to each of those parentheses. And so there's the cross product. Now I need to actually do the multiplying. So 35c plus 20 equals 6c minus 9. And if you are okay with the solving equation questions from above, then this equation is now in the same spot. So we have variables on both sides. I'm going to subtract 6c on both sides. Gives me 29c plus 20 equals negative 9. Going to subtract 20 on both sides. That gives me negative 29. So 29c equals negative 29. Divide by 29 on both sides by positive 29. And c equals negative 1. Last one for proportions, solving proportions. Again, cross multiply. Notice how this is the only one that has terms that need to be grouped. So the 9 minus x. This negative 2x is not something that you have to distribute to, it's just you need to multiply. So 2 times negative 2x is negative 4x. And then set that equal to 3 times the quantity, 9 minus x. Okay. So negative 4x equals, and then we're distributing, so 27 times 3 times negative 1x is negative 3x. Once again, we have variables on both sides. So this minus 3x, this minus 4x, they're on opposite sides, so I need to do opposite operations here to bring them together. So I'm adding 3x to both sides, cancel that out here, and I still have negative 1x equals 27, and then divide by negative 1. So x equals negative 27. All right, these two questions are proportion word problems, and for proportion word problems, it's helpful to set up a unit fraction. So let's read through it once, and then we'll set that unit fraction up, and then identify the proportion that we need to set up. So if it took the teacher 10 minutes to grade 2 quizzes, how long would it take her to grade her class of 22 quizzes? So we're talking about 10 minutes to grade 2 quizzes. How long will it take to grade 22 quizzes? So we're talking about minutes per quiz. Okay, so that's my unit fraction. So based on that unit fraction, I'm going to write an equation, which is a fraction set equal to a fraction. I'm going to write a proportion. Using this information, it says 10 over 2, because 10 is the minutes, 2 are the quizzes. How long is it going to take to grade 22 quizzes? Well, 22 goes on bottom of the second fraction because it is the quiz number. We don't know how long it's going to take, so we'll say hours, or time, I guess you should say minutes, M for minutes. So once we have that proportion set up, then this is now just cross multiplying. So 2m equals 220, and solve. So m equals 110. That means 110 minutes is how long it will take to grade the class of 22 quizzes. For the second one, it says 25 pencils cost $10. So 25 pencils cost $10. How much would 10 pencils cost at the same store, right? So we were trying to figure out how much the cost is, right? So how much 10 pencils cost at the same store. So our unit fraction, I'm just going to go in order of the information given. So pencils per cost or per dollar. So my unit fraction is going to be pencils over dollars, which means I have 25 over 10. And we know 10 pencils. We know we're buying 10 pencils, and we don't know the cost. So C. Okay, so there's my proportion, and now I'm going to go ahead and cross multiply. So 25C equals 10 times 10 is 100. Divide by 25. And C equals 4. So $4 would be your final cost. Okay, in this last section, we'll take a look at finding some errors and then just some special case issues. So again, if you haven't tried them yet, try them out and then follow along, or use the video to check your work. In this case, we're finding the error. We're finding the error in the work, and then we're going to correct it, right? So let's just start by taking a look at the first equation and that first step. It looks like they tried to combine like terms. So it looks like those two things are like terms, and they put those together to get 8x. Okay, so right there, right? 5 minus 3 is not 8. Okay, so it looks like they added 3x and added 3x to cancel it out, but we don't need to do that because those are on the same side. Those are on the same side of the equal sign. So in this case, what they really need to do is just add them together, which 5 plus negative 3, or 5 minus 3, this right here should be a 2x. Okay, so let's start right there in the correct work. So after that first step, it should be 2x plus 3 equals 4x plus 11. So our error, right? Let's explain that down here. When they combined like terms, they added 3x instead of subtracting from 5x. So that like term is supposed to be 2x. At this point, we're solving this equation, which we've been practicing a bit in this video. So I'm going to subtract 4x on both sides. Gives me negative 2x plus 3 equals 11. And then business as usual, subtract 3. We get 8 left over on the right, and then divide by negative 2. So x equals negative 4. And lastly, take a look at some special cases here mixed in with the normal solution. So when we solve equations, we can either have infinite solutions, no solutions, or exactly one solution. Exactly one solution is what normally happens. This would be things like x equals 1, or even x equals 0, or x equals -5. Whenever you have a variable left and then a number, that is one solution. No solution is when you see things like -5 equals -7, -6 rather. That's not true, but notice there's no variables. Infinite solution would be something like 2 equals 2, right? That's true, but there's still no variables. So if the variables cancel out, that's when we have infinite or no solution. If there's still a variable left, then we would have one solution in the end. So let's take a look at letter A. Let's go ahead and solve. So again, normally what we do, distribute. And then at this point, some of you might remember that you can determine the solution from here, because I noticed that they have the same coefficients and the same constant. And if that's the case, this is going to be infinite solutions. But if you're not sure how I can see that, well, let's try to get the variables to the same side. So I'm going to subtract 2x to cancel it out on the right. I'm subtracting 2x to cancel it out on and it cancels out on the left. So that right there is what happens. The variables cancel out, and I'm left with a statement that is true. So this is infinite solutions, right? -6 is equal to -6. They match. Let's check out letter B here. So again, distribute. We get 3x minus 9. And right here, I can again tell my final answer. So notice how the coefficients of each variable match. So those are going to cancel out. But the constants, -3 and -9, don't match. So when I go to subtract 3x on both sides, the variables are gone, but the numbers I'm left with don't match. -3 is not equal to -9. This is no solution. Letter C, here we go. So distribute. And then at this point, we have some like terms I see on the right-hand side. 2x minus 2x. Those cancel out. Combine those together, that just cancels out. So I have 2x minus 1 equals -4. And now notice I do have still a variable term though. I still have a variable on this side. Okay, so we can finish solving this, but what I know is that there will be one solution. Right, one solution. And so if you add 1 to both sides, I have 2x equals -3. Divide by 2, and that one solution is -3 over 2. All right, last one here. Again, lots to combine, a little bit to simplify. So let's go ahead and do that. 3 times x is 3x. 3 times -2 is -6. On the right-hand side, I see there's a 2x and a 1x. Put those together for a 3x. And a +2 and a +1. So that's 3. So think about back to what we talked about over here, right? If you look at the coefficients of the variables, they're both 3. So the variables match. So that means the variables will cancel out. So if you need to see that, here's what happens. We subtract 3x from both sides, and the variables completely cancel out. And we're left with -6 equals 3. That is not true. -6 does not equal 3. So once again, that is no solution.